Alright, so kita sambung. So this one is measures of variation. So we're going to look at the first one, that is range. So what is range is all about? So basically when we talk about range, so range is basically the difference between the largest value with the smallest value. Okay, so maknanya you ambil nilai maksimum dalam dataset anda dan you tolakkan dengan nilai minimum. So you just need to take the largest minus the lowest value. Okay, so for example, let's say if you have a value something similar to the previous one, so let's just get back the data from the previous materials. So kita tengok balik data yang sebelum ni, kita ambil balik data tu, and then kita try gunakan this one. Mana data kita where is it? Hilang dah. Okay, this one. Okay, suppose that we take this data balik. So kita try ambil balik data ni. So I just gonna use the arrange data. So kita ambil balik data ni. Control C. Okay. Okay, we're gonna use the same data set. Okay, suppose that you have this data set. So you ada data set ni. Okay, so when we talk about the range, so basically we are just looking at the value from the highest to the lowest. So we just take the difference between the highest to the lowest. So in this situation right now, if you look through this information, you have the largest to be 239, and then the lowest is 121, right? So in this situation, you can get the value of the range. Here is just simply equal to 239 minus 121. So calculate this one, you should get okay, 118, right? So you get 118, for example, in this case. Okay, so you get the value to be 118. So this is the value of the range. So basically it's just simply taking the largest value minus the lowest value. Alright, so again, similar to the value of mean, range value is not robust and it is affected by the existence of the extreme values ataupun outliers. Okay, so in this case, range is always this is not robust, and then it means that it is affected by outliers. Okay, so these outliers can be any value that is too large or any value that is too small. For example, suppose that you have, instead of having the largest value to be 239, so maybe this value is actually 932. Okay, 932. So that means if this is the final values or the largest value, it will give an effect to your range value. Okay, maknanya kat sini your new range akan jadi 932 minus 121. minus 121. So this will give you the values to be 811. Okay, instead of 118 dah jadi 811. So you can see that here, if you have an outlier, then it will affect your range value, and your range value will be misleading to explain about the whole data set. Okay, so inilah yang berlaku sekiranya kita ada satu nilai yang terlampau besar atau terlampau kecil. Kita tak dapat gambaran yang sebenar berkenaan dengan situasi dalam data tersebut, kerana nilai range ni akan dipengaruhi oleh nilai yang besar ataupun nilai yang kecil. Okay, so in term of variation ataupun in term of dispersion of a data set, if you want to compare using range, so what you need to do is to find range with the lowest value. So range with the lowest value means that the data is less dispersed or more consistent. Okay, so bila katakan less dispersed or more consistent, that means the value is close to one another. Okay, dia punya serakan tu adalah tidak jauh daripada antara satu sama lain. So the distance between one variable with the other is not so large compared to the one with the higher value of range. Macam ni So compare this one. So this one will be less dispersed. Contohnya So this is less dispersed, ataupun kita boleh katakan sebagai more consistent. Okay, more consistent lah data. Okay, tapi kalau yang ni dia more dispersed sebab dia lebih jauh antara satu sama lain. Tapi kena ingat bahawa yang kedua tu dia punya nilai range adalah dipengaruhi oleh wujudnya nilai outliers ataupun nilai extreme values yang terlalu besar. Okay, alright. So that is in the form of range. And then the second one that we're going to look at is what we call as variance. Okay, kita akan tengok pada variance. So what is variance is all about? Okay, apa itu variance sebenarnya? Okay, so what is actually a variance? Okay, so tadi kita tengok range. Now we look at variance. Okay, kita tengok pula apa yang dimaksudkan dengan variance. Seluruh pula line saya. Okay, what is variance? So in this situation, it says here the variance is a numerical measures of how the data values is dispersed around the mean. Dispersed around the mean. Tadi kita just tengok dispersion, dia tidak ada dia punya reference point. It doesn't have a reference point. But for variance, it has a reference point where the reference point used in variance is the mean value. So that means you need to find the mean value in order to determine whether your data is dispersed or not. Okay, is there exists a large variation between the data, or is it exists a low variation between the data ataupun small variation? So in this case, variance it just look in terms of the distance between one data with the mean value. So dengan kata lain kat sini dia kena ada nilai mean lah. So in particular the sample variance is defined as, so kita boleh dapatkan sample variance dan juga kita boleh dapatkan population variance. So you have to know to differentiate between these two. You kena tahu macam mana kita nak tahu yang tu adalah sample variance dan macam mana kita nak tahu yang satu lagi tu adalah population variance. Okay, this is just by using the symbol. So we look at the formula for the population variance first. And for variance, we use the notation sigma square. Okay, we use the notation sigma square, and this is given by the formula 1 over n okay, and then multiply with okay, okay, multiply with the summation of x minus x bar, okay, xi minus x bar square. Okay, so in this situation kita akan gunakan nilai dalam bentuk okay, sorry, dalam bentuk ni lah, dalam bentuk kuasa 2n sorry, yang this one supposed to be, this one is for the population so population kita tak boleh gunakan x bar. So populasi, untuk populasi the parameter for mean is mu. Okay, so we have to get xi here is actually the value of the data. Okay, the data minus the mean value, and then you square them. Lastly, you add all of them together and divide by 1 over n. Okay, you divide by 1 over n. Okay, so in this situation, so this is for the population. How do you know this is for the population? One is by the formula itself. You see that the notation used is the Greek letter words, and the population size is the capital letter N, and also the mean is being denoted by mu. So this is for the populations. All right. What about for the sample? Of course, for sample, it will be very much the same. Cuma ada beza sikit saja sebab dia punya penggunaan sample. So, we have the formula to be s square equal to, but this one gonna be 1 over n minus 1, and then multiply with summation of xi minus x bar. So instead of mu, the mean for sample is x bar to the power of 2. Okay, so this is the formula. And then why is it you have n minus 1 over here? So the n minus 1 over here means that whenever you estimate the standard deviation, the variance, you lose 1 degrees of freedom. So kenapa kita hilang degrees of freedom? You can dig the information on degrees of freedom dalam teks. So what it means by you lose 1 degree of freedom, why minus 1? Because whenever you want to calculate the variance, you need to estimate the value of x bar first. Okay, because you estimate one parameter here ataupun you estimate one statistic here, that is why you lose 1 degrees of freedom. Okay, so you have n minus 1 over here. If you have to estimate 2 statistics in order to calculate the third statistic, then you're going to lose 2 degrees of freedom. Nanti you akan tengoklah kenapa bila kita masuk pada tajuk hypothesis testing, why whenever we use the student's t distribution, we lose 2 degrees of freedom. Because in student's t distribution, you estimate 2 estimators. When you estimate 2 estimators, so you lose 2 degrees of freedom in order to calculate the value of t. Okay, so nanti itu yang kita akan masuk pada sesi untuk perbincangan estimation. Okay, this formula can be simplified for the use of your calculator directly, and the use of calculator to find the standard deviation is shown in my YouTube channel. You can just watch my YouTube channel, bawah topics ataupun playlist easy stat. You tengok dekat bawah playlist easy stat tu ada cara-cara untuk kita mean dan standard deviation. Okay, this also can be written as, saya tunjuk satu saja untuk yang sample. It can be written as 1 over n minus 1, and then multiply with the summation of xi square minus summation of xi, the whole thing square, divided by n. Okay, so this is another formula, and this formula can be used with your calculator, because using your calculator you can find the value of summation of x square and also the summation of x. Okay, you can find these two values from your calculator directly whenever you enter your data into the calculator. Okay, alright, so if you want to find the standard deviation for the above data, you can just easily find the values. Okay, saya macam mana boleh. Alright, so how to find this value, you boleh carilah dekat dalam saya punya YouTube, boleh tengok kat dalam saya YouTube. Tapi kalau kita nak buat secara manual, what you need to do is to find the summation of xi first and then summation of x square. Okay, I will be doing this quickly on my calculator to get the values. Ataupun kalau nak gunakan SPSS pun, nak gunakan Excel pun boleh. So nak gunakan Excel pun boleh. So kita tengok macam mana. So let me just get the information. Okay, suppose that you get this value. So contohnya kat sini kita dapatkan nilai summation of x ni dengan summation of x squared. So let's just get the value first. Okay, we need to find the summation of x and also the summation of x squared. Okay, how to find the summation of x and summation of x squared? Mana pula kalkulator saya? Okay, kita boleh you can calculate together with me very fast. Okay, kalau sesiapa yang ada calculator yang boleh nak cuba nak gunakan sekali dengan saya, boleh saja. So I will just say what you have to do and then you just follow. Okay, in order to find the mean and the standard deviation, the first thing that you need to do if you are using Casio 570 MS or 570 something, bukan yang barunya, so yang barunya kita tengok dekat dalam saya punya YouTube channel. So first thing that you need to do is to change the mode of your calculator into SD. Okay, into SD. So yang ni sama saja mana-mana. Cari je yang ada SD. So sampai you dapat SD, you tekanlah SD tu sama dengan 1. Okay, so now when you already in the SD mode ataupun standard deviation mode, you can see that on your calculator screen it will show SD. Okay, so next is to enter the data. So since this is a raw data set, so you can just key in directly, and then to store the data you have to press the key M plus. Okay, M plus, you kena press the key M plus. So you kena press key M plus lah untuk store data. Okay, this one is to store data in calculator. Okay, simbol ni biasanya key ni biasanya ada di atas yang AC button warna merah tu lah. Okay, so let's just enter this value. So I have 121, so 121 M plus, and then 142 M plus, and then 148 M plus, 152, 154, and then 156, 160, 165, 175, 188, and finally you have 239. Okay, you have n equal to 11. So once you have entered the values or the data into your calculator, the next thing to do is to find the summation value. So you need to find summation value, you press the shift and number 1 button. Okay, bila you press shift and number 1 button, it will show on your screen three options. Sebentar Ya, masuk.
Assalamualaikum Sir. Sorry
Assalamualaikum.
ganggu.
Ya.
Saya
Okay, saya sambung kelas just tulis and then alright, so kat mana tadi? Okay, saya dah kira tadi kan. So you akan dapat dekat display tu, you akan dapat dia punya apa yang di display dekat your punya calculator tu. It will be the first one is summation of x square, and then the second one you will see that you can summation of x, and the third one is the value for n. So suppose that you want the summation of x, that is for the second option. You just press number 2 and then press the equal sign to activate the selection. So when press the equal sign, you will get the answer to be 1800. Okay, you get this one to be 1800. Okay, and then to get the summation of x square, just do the same procedure just now. Press shift button and number 1, and it will give you the option again. Right now you want for the first one, that is the first option, summation of x square. So you press number 1 and then press the equal sign. So you get the value here to be 303,780. Okay, that is the two values needed to calculate the standard deviation. So what you need to do is just simply replacing this value in the formula. Okay, you're gonna replace these two values in the formula and calculate the variance value. Okay, calculate the variance. So in this situation, you know that the value of n here is equal to 11, right? So this one is equal to 11. So 11 minus 1. Need to do is just simply substitute. If you want to calculate manually, you can calculate the values manually, or you can get the answer from your calculator. To get the answer from your calculator, what you just need to do is just press shift number 2. Okay, under shift number 2, it will give you three options. Okay, it give you three options. The first option is x bar. So this is the first option, and then you have sigma x. So this is the second option, and you have sx. This is the third option. Okay, your formula is s squared. Okay, your formula is s squared. So you will look at the third one, right? But you have to square the values in order to find the variance, because the one that is given to you in your calculator is the standard deviation result. Okay, it's not the variance, but since right now we are calculating the variance, so the variance you need to square the value that you obtain from the calculator. So in this case, I will choose number 3 and then I will square the values. So I will choose number 3 and then just click on or press the square button. So you will have the sx square, and to get the answer, just press the equal sign. So whenever you press the equal sign, you get this value to be 923.45. Okay, so that is the variance. Okay, that is the variance. Okay, so this is the values for the variance, and meanwhile for the standard deviation, normally in statistics, whenever we want to make comparison or whenever we want to explain regarding certain information on the data set, regarding the variation of the data set, normally we will be using the standard deviation instead of the variance. Okay, so kita akan gunakan standard deviation. So what is standard deviation is all about? So basically, standard deviation is simply the same as what we have in the form of a variance. Cuma perbezaannya kat sini adalah bila standard deviation ni we take the square root of the variance. Okay, so in this situation, if you look through this one, the standard deviation of an observation variable is the square root of its variance. So that means in this situation, in order to find the standard deviation, so what you need to do is just simply find the square root of the variance. So in this situation, the standard deviation is just simply the square root of the variance. So which means that if you want to find the standard deviation of a sample, for example, the above part here, you just need to say S is equal the square root of S squared. Or if for the population, it will be sigma is equal to the square root of sigma square. So in our situation right now, so we have this to be equal to, so this gonna be the square root of 923.45, or you can just simply use the calculator just now, shift number 2 and then choose number 3, so you get the answer to be 30.39. so you get here to be 30. If we take 3 decimal place, it will be 388. Okay, it will be 388. Alright. So what does this mean whenever we have this kind of situation? So apa maksudnya ke sini? All this value. So saya nak asingkan dulu yang ni. Let me just take this one. Mana pergilah. Okay, let me get this one first. Saya nak asingkan dulu. Nanti dia Ctrl X. Okay. Okay, what does this mean? So bila katakan kita ada standard deviation 30.388. So how does it relate to the mean value? Because just now bila kita tengok dekat dia punya definasi tadi, kita katakan dekat sini, the variance is a numerical measures of how the data values is dispersed around the mean. Maksudnya di sekitar mean. So if you draw a distribution, something like this. Okay, let's say you have a distribution something like this. And suppose that this is the mean. Okay, this is the mean. Okay, the mean population. Ataupun kita gunakan X bar so kita gunakan yang sample So okay, so we look at the sample. How, because yang ni kita gunakan sample kan. Okay, we look at the sample. Okay, suppose that you have the mean over here. So this is the mean sample. It says here, if you have within one standard deviation. So within one standard deviation is that from the mean, you have a distance of one standard deviation to the left and to the right. So suppose that you have here, this is 1 S or 1 sigma. Okay, kita boleh gunakan S atau sigma. So yang ni untuk populasi. So this one is related to population. Okay, so whenever we have this kind of situation, okay, let me just draw it a little bit different here. So suppose that we have this thing. Okay, so what it says here, 68 around approximately 68% of the data lie within the one standard deviation. So maksudnya between these two values lah. So dengan kata lain, kalau kita relate dengan kita punya values tadi, let's say here you have your distribution, and then you have the mean here. So the mean, if I calculate the mean over here, the mean is 100.6, so 163.6. So this is 163.6. Okay, if you say that within one standard deviation, so that means you minus the one standard deviation and minus 2 standard deviation. Okay, so if you plus the standard deviation 30.388, so you get the upper bound here to be 194. Okay, you have here 194. If you minus, you're going to get the value to be 133. Okay, approximately the value will be 133. Okay, what it says here, if you take between these two values, your data set that inside these two values will be approximately 68% of the total data that you have in your data set. So kalau kita tengok dekat sini, kita punya data tadi, kita ada okay, between 133, so this is 133, so and then 194. So this is all 133. So it is more than that already. Okay, so kita ada 9 dekat sini. Okay, we have 9. So a normal distribution will say that 68% of your data set will lie between one standard deviation, and it will lie about 95.4% standard deviation. This is 2 standard deviation, negative 2 standard deviation. So kalau yang ni between 2 standard deviation, it is approximately 95.4%. And then within 3 standard deviation, it will be 3 standard deviation plus minus, it will be around 98.3 standard deviation. 98.3 saya tak salah saya, ataupun 99.4. Kena check dengan buku So please check in the textbook. Saya pun tak berapa nak ingat the values Be around that So in this case, kita identify it should be around this value, 68% within the one standard deviation. So ini yang dia katakan disperse around the mean So data ni dia just sekitar sini saja. So satu standard deviation maksudnya sekitar ni. Alright, so that what it means by disperse around the mean, because the value of the data, the distance of the data is respective to the mean. Okay, respective to the mean value. So kalau yang ni kita ada 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 daripada 12 lah. Yang ni dia lebih sikit sebab dia tak bell shape So you take 9 divided by 11. So you get around 81%. Okay, so still within this one lah. So you akan dapat 81% kalau macam ni. Okay, so a bit above the 68%, so you can say that this is not a normal curve lah. Sebab kalau 81% ni maknanya terlalu banyak, dia punya gambar rajah tu akan jadi macam ni lah. So dia punya distribution tu, it should be something looking like this. So it will be something like this. Dia akan lebih tinggi macam tu. Okay, sebab dia banyak kat sini. Okay, so dia akan jadi, dia punya kurtosis akan tinggi lah. So kurtosis tu dia punya peak tu tinggi. Okay, there's too much data in the data set within one standard deviation. The normal curve will be having approximately 68% saja. Tapi kalau yang data yang kita ada ni is already 81%, so it is not particularly follow a normal curve actually. Okay, so that is basically what it means by the variance dengan standard deviation. Any questions so far? Boleh follow? Boleh? Okay, the next thing that we're gonna look at is what we call as quartile. Okay, kita nak tengok quartile pula. So, macam mana kita nak kirakan quartile? So, let me get the data again so that I can show you the quartile. So, yang ni saya ingat saya nak pindahkan ke bawah. Kita pergi ke bawah. So, let's take this to the bottom. Supaya kita ada more space lah. Kita tak boleh bawa ke bawah. Ikut Alah, tak boleh bawa ke bawah lah pula. Alah, kita cut dulu. Ctrl X. So, kita letak ke bawah ni. Okay, and I will take the previous data so to work on. Kita ambil balik data kita yang tadi. Kita akan work with the same data set. Ctrl C. Okay. So let's work on this data set again. Ctrl V. Okay, so let's look at what it means by quartile. Okay, kita tengok pula quartile. So what it means by quartile, what it means by interquartile range, and how to calculate the box, how to come up with a box plot, and also what it means by skewness. Okay, and then bolehlah kita bersurai. Okay, so what is quartile? So basically, when we talk about quartile, so quartile is actually a similar thing to median. The only difference right now, if median, you divide the data into two equal parts. So we divide into half. For quartile, we divide it into 4 equal parts. So kita pecahkan pada 4 bahagian yang sama besar. Okay. So you want to calculate the quartile. So the quartile is basically there are several quartiles of an observation variable. You have the first quartile, the lower quartile, and the value that cuts the first 25% of the data. Okay. So in this situation, when we talk about quartile, so kalau median kita pecahkan pada dua bahagian, betul tak? So in this case, if you have a median, so basically when you have a distribution, the median will cut the data into two equal parts, isn't it? So one on the left, the other one on the right, which means that half of it will be less than the median value and half of it will be greater than the median value. For quartile, instead of just dividing it into two, it's further divide the half into another half. So that means it will divide to here and also here. Okay, so instead of 50%, 50%, right now you have 25% over here, you have 25% over here, you have 25% over here, and then finally you have 25% over here. Okay, so this gives you 3 quartile values. So that means to divide the data set into 4 equal parts, you need 3 cut points, which are the quartiles. So you have the first quartile over here. This is Q1. This is Q2, the second quartile, and the third one is the third quartile. Remember that this one the quartile 2, this is just simply the same as the median. So that means if you already have the value for the median, you don't have to calculate the Q2 anymore, because the Q2 value is just the same as the median. Okay, what you have here right now will be calculating the Q1 and Q3. Okay, what does Q1 tells you and what does Q3 tells you? Okay, in general, when you have Q1, okay, saya pecahkan ni pada dua. Okay, you have Q1. So first you have for Q1, so you have this kind of situation. Boleh nampak So right now you have Q1 over here. So this is Q1. Okay, what it says here, 25% of your data will be less than the Q1 value. Meanwhile, 75% of your data will be greater than the Q1 values. Okay, so maknanya kalau untuk median kita half-half kan. Tapi kalau untuk quartile, 25% less than the quartile value and 75% greater than the quartile value for the Q1 cutting point. Okay, but for the Q3 it will be reverse. So Q3 dia macam ni. Sebab Q3 dia ada berita sebelah kanan so it will be somewhere here. So this is Q3. So which means that right now 75% of your data is less than Q3 and 25% of your data is greater than Q3. Okay, so that is the situation whereby this situation you need to really understood it correctly and make sure that you don't make any mistake whenever explaining or interpreting the value of Q1 and Q3, because you have to be very careful with the 75% and the 25%, whether it is greater or less than. Okay, boleh boleh follow ke? Are all of you okay? Boleh na? Okay, now let's look at how we can calculate the quartile value. So similar to the one that you have in median, the only difference right now is you divide by 4. Kalau untuk median kita divide by 2, right? And then this one you divide by 4, and there is an indicator whether it is a first quartile or the second quartile. So macam biasa, the first step that you need to do in order to calculate the quartile, so first kali apa yang perlu kita buat adalah kita perlu arrange data or order the data ataupun arrange the data macam ni lah. So yang ni is already arranged, right? So from the lowest to the highest. Okay, the second step is to determine the location. Okay, determine the location. Okay, to determine location, so right now you have 1 and 3. Yang 2 ni kita tak perlulah sebab yang 2 ni sama dengan median. So location is given by I times n plus 1 divided by 4. Okay, where I here can either be 1, 2 or 3. Okay, depending on the location, depending on the quartile that you want to find. If you are looking for quartile 1, so that means I will be replaced by 1. If you are looking for quartile 2, so you replace I with 2. So it goes back to n plus 1 divided by 2, which is equal to the location of the median. And then for the third quartile, just substitute with 3. And then third is to determine or calculate or find the actual find the quartile value. Okay, there. Alright, so find the quartile value. So how? Let me just show you how we can find one of the quartile. So kita cari yang Q1 So we find Q1. Okay, kita cari Q1 So how to find Q1? Okay, data is already in order, right? So you don't need to order anymore. So next you have to find the location. Okay, the location is just simply n plus 1 divided by 4, since this one is multiplied with 1, right? Sebab kita nakkan 1 saja kan. Q1 So kalau 3, kita tinggal 3 lah. So in this case, you have 11 plus 1 divided by 4. So 12 divided by 4 will be simply 12 bagi dengan 4 dapat sama juga. Saya tak nak guna ni. Sebab yang ni dia akan dapat nombor yang sama Tak apalah. Alright. Okay, 11 plus 1 divided by 4, so you get this with 12 divided by 4, that is the third position, right? So that means you have the third position. So next you can find the quartile 1 to be, so locate the third position, so 1, 2, 3. So that means this is quartile 1. So 148. Okay, for quartile 3, if you want to find for quartile 3, so untuk quartile yang ketiga, so you need to find 3 times n plus 1 divided by 4. So in this case, when you calculate this one, you get 9, isn't it? So this gives you quartile 3 to be equal to the 9th position. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 7, 5. So it will be 1, 7, 5. Okay, so that is how you find the value of quartile. Okay, if you have, this is whenever you have an even numbers. Okay, whenever you have an odd numbers. So if you have an odd numbers, either you can get the value to be, the position to be an integer, or the position will be 0.5. Okay, 3.5, 4.5, and so on. But if you are having the values to the number of data that you have in the data set is even numbers. Okay, it's even numbers. So you're gonna have the location to be in the form of decimal point, 0.25 or 0.75. So if this is the situation, then you have to be very, very careful to calculate the quartile values. Okay, please look the example in the textbooks, or you can just look at the YouTube channel that I have under the playlist Easy Step. Okay, boleh tengok kat situ macam mana nak kira. Right, so this is the quartile value. So that means you have quartile 148 and 175. Alright, so the next thing that we're going to look is what it means by interquartile range. So just now kita ada range sahaja, but now we have interquartile range. So what is interquartile range right now? So interquartile range is simply the upper quartile minus the lower quartile. Okay, so this one is supposed to be, okay, this is supposed to be okay. Okay, so the interquartile range is just simply the difference between the upper quartile and the lower quartile. So what is the upper quartile? So upper quartile ni maksudnya Q3. So this is Q3. And then minus the lower quartile. The lower quartile will be Q1. Okay. What does the interquartile range tells you about? Okay. So the interquartile range give you an information on the distribution of the data in the main body of the data set. Main body itu maksudnya the 50% in the middle. Okay, sebab bila kita dapatkan dalam bentuk gambar rajah data taburan data, so we have this distribution and then we have the Q1 and Q3. So you have Q1 over here and then you have Q3 over here. So the interquartile range is basically the difference between these two values. So this is IQR. And this IQR consists of 50% of your data set. So when it consists of 50% of your data set, so this can be a guideline to show that it is approximately normal. You know that for the normal distribution, the bell shape, it should be 68%, right? So this is just close to the normal distribution. It's not normal, but it is close to normal distribution. Okay, so this is the part that we call as the 50% of the main body. So this part adalah, this part is the 50% of the main body for a data set. Okay, so in this situation, so you can find the value of the interquartile range. For this example, you have the IQR is equal to 175 minus 148. Okay, so this gives you 27 unit. Okay, so the IQR will be 27. So what is the use of this IQR? So this IQR can be used to compare the distribution between two or more groups. Okay, the distribution between two or more group. This is similar to the one yang kita tengok sini, sama ada dia adakah dia more consistent ataupun adakah dia more dispersed. Okay, so is it more consistent or more dispersed? So you can use interquartile range to compare between groups. So how to compare? Look at the values with the lowest IQR if you want the data to be consistent. Okay, which means that data set with a lower IQR is more consistent with a data set with high IQR. Contohnya kita ada IQR A 27, IQR B 48 contohnya. So that means IQR A lebih kecil daripada IQR B. So which means that the data distributed in the group A is more consistent compared to group B because the IQR in group A is smaller than the IQR in group B. Okay, so itu sebagai satu contoh. Okay, that is basically what it means by interquartile range. And based on this all information that we have learned just now, we can construct a box-whisker plot ataupun kita simply panggil sebagai box plot, or we can also call this as box and whisker plot ataupun diagram. Okay, kita boleh kira the box and whisker plot ataupun just simply box plot. Okay, the box plot of an observation is a graphical representation based on its quartile as well as its smallest and largest values. It attempts to provide a visual shape of the data distribution. Okay, dia nak bagi sedikit visual shape of the data distribution. Okay, how do we come up with the box and whisker plot? In order to draw a box and whisker plot, we need what we call as the 5 number summary. Okay, kita perlukan apa yang kita panggil sebagai 5 number summary. Okay, what is meant by 5 number summary? The 5 number summary give you the information for 5 measures. What are the measures? So it is the X min, that means the minimum value or the smallest value. And then you have the quartile 1. You have the quartile 2. Okay, the quartile 2, this is similar to median value. Quartile 3. And finally, the maximum value. Okay, and based on these 5 measures summary, 5 summary measures, you can construct a box and whisker plot. So the box and whisker plot consists of all these 5 values, or maybe just 3, and the other 2 maybe it is hidden. Okay, hidden in the graph because of the outliers. Okay, kalau ada outliers, the minimum and maximum will not be shown on the graph itself. So dia akan just letak sebagai outliers. Okay, dia tak ada dia punya penghujung, tapi dia akan ada dalam bentuk outliers. Ada hujung dah, tapi dalam bentuk outliers, bukan dalam bentuk palang. So nanti saya akan tunjukkan. Okay, so in this situation, if you want to draw the box and whisker plot, you need all these 5 values. So what are the 5 values here? So you have the minimum to be 121, the maximum is 239. And then the median you have to calculate lah. So 1, 2, 3, 4, 5. So this one is the median, right? So this is the median. Okay, 121, 156, 239. Okay, 121, 156, 239. So you get here 121, 156, and then this one is 239. And then just now we have calculated the Q1 and Q3, right? So Q1 is 148, and then Q3 is 175. Okay, so macam ni kita nak bina dari box and whisker plot. Just put this at the bottom. Okay, now we're going to construct our box and whisker plot. So macam mana kita nak construct box and whisker plot kita? Okay, first you need the scale. So you kena tuliskan dia punya scale dulu lah. So you need the scale. Okay, you need the scale. So in this case, your scale, the lowest in 121, the highest is 239. So mungkin kita boleh gunakan a scale of 10 lah kot. So kita buat 10 scale. A scale of interval 10. So 120, 130, 140, 150, 160, 170, 180, 200, and then 210, 20, 230, and finally 240. Okay, next what you need to do is to locate your values for each of these 5 number summary. So the first one you have is 1 to 1. So kita ada 1 to 1 kat sini. And then we have 148. So kalau nak mudah terus buat palang. Saya just tandakan dulu. And then you have 156 over here. And then you have 175 somewhere here. And finally you have 239. Okay. So apa nak buat? So kita akan buat kotak lah. So di tengah-tengah ni dia akan ada kotak. So kita ambil 3 data yang di tengah-tengah ni, kita buat kotak antara dia. Okay, so kita buat kotak. So this is the box. And then the median value here, we just draw a vertical line representing the median value. And what happened to the rest of the data? So for the mean, from the box, in the middle of the box, just draw a horizontal line to the point on the left and right, and then just do the bar. Same thing on the left to the bar. So this is your box and whisker plot. Okay, so this is your box and whisker plot, and this box and whisker plot will give you the shape of the distribution. How do you know the shape of the distribution? Basically, you know the shape of the distribution by examining the median value, the median in the box, and the length of the whiskers ataupun dia punya tail. So dia punya box dengan tail dia. So this one is the tail, this is the whiskers, and this will be the box. So you boleh examine this thing. So kalau katakan data tu adalah tertabur secara normal macam ni. So your box and whisker plot should be something like this. Okay, kalau tertabur secara normal, maka you punya data, median dia akan berada di tengah-tengah kotak dan panjang whisker mesti sama, kiri dan kanan. If your data is skewed to the right, something like this, okay, then your distribution will look something like this according to the box and whisker plot. Okay, the median in the box will be closer to the left side, to Q1, and the length of the right whisker is longer than the left whisker. And then kalau untuk yang ketiga, okay, saya turunkan yang ni sikit. Okay, so kalau yang ketiga, if you have a left skewed distribution, so it will be something like this. So this is left skewed, and your data will look something like this. Your box and whisker plot will look something like this. Okay, whereby you have the whiskers is longer on the left side, and the median is closer to the Q1 value on the right side. So this is left skewed. So basically, if you look through your data set just now, you can see that is it left, right, or symmetry. So this is symmetry. This is right skewed. And this is left skewed. Okay, so basically, if you look this one, it is similar to the second one, right? So number 1, number 2, number 3. So kalau you tengok yang ni, bentuk ni lebih kurang sama macam yang sebelah kanan ni kan, yang number 2. So that means the data is right skewed. So you can say shape of the distribution. Kalau katakan the shape of ataupun this shape of distribution, you can say that this one, this is a right skewed distribution. Okay, right skewed distribution. Okay, so this is what you have in the form of the box and whisker plot. And finally, you can also determine the skewness or the skewness of the distribution using certain measures. Okay, so yang ni kita boleh juga panggil sebagai positive skewed Kalau yang negatif tu left tu negatif. So you boleh juga gunakan measures So this is what we call as the Pearson measures of skewness. And there are two methods or two ways you can calculate the Pearson measures of skewness. So saya juga gunakan Pearson measures of skewness, PMS So you can use the difference between the mean and the mode, the mean minus the mode, Okay, the mean minus the mode divided by the standard deviation, or you can use PMS, special measures of skewness, to be 3 values of the mean minus the median, and then divided by the standard deviation. Okay, for our example just now, you can use the second one because you know the value of median, right? So you can find the PMS for this one. So PMS is equal to 3 times mean. What is the value of mean just now? Kita kena mean tak? Kat atas kan? Nampaknya. Mana mean kita tadi Saya kira dah mean kan? Mana mean saya? Oh ni tadi So mean kita tadi adalah 163.6 So you have this to be 163.6 minus the median. We just calculate the median just now. So the median is given by 156. Okay, you have 156. And then you divide by the standard deviation. So just now you have the standard deviation to be 30.38 So just put as 30.4 So you have here to be 30.4. So you calculate this value. So if you calculate this value, you have 163.6 minus 156. And then times 3, you divide by 30.4. So you get the value to be 0.75. 0.75. So this is greater than 0, right? So which is positive. Betul, right? So this is positive. So this indicates that your data distribution is positively skewed because the value is positive. If you get the value to be PMS to be negative, then your data distribution is negatively skewed. If you have the value to be approximately 0, then you have the skewness to be normally distributed. Okay, so that is what it means by skewness using the Pearson measures of skewness. So you determine the skewness based on the result, whether is it positive, negative, or 0. For PMS greater than 0, you have a right skewed distribution. For PMS less than 0, you have a left skewed distribution or negatively skewed. And if the PMS is approximately equal to 0, then you have a symmetrical distribution. Okay? Alright, so I think we have finished chapter 2. Okay, kita dah habis dengan chapter 2. Alright, so saya rasa sampai kat situ dulu lah kot Any questions so far?
No, sir.